He's really good for me. Alright, day 2. Opener, weird things are happening. How many solutions? 4. Why? Degree is 4. We know that because we have an x squared here, and it's multiplying by an x squared here to make x to the 4th. Y-intercept, that happens when?
X is 0.
X equals 0. I do want you to show work for that, so f of 0 equals, we've got 0 minus 3 squared, and then I'm going to use a bracket because I'm going to have to use more parentheses on the inside. I've got 0 squared plus 6 times 0 plus 9. What's 0 minus 3? Negative 3. That's being squared in the front, and then 0 squared is 0. 6 times 0 is 0, so I'm left with 9. And then negative 3 squared is 9, and that's multiplied by 9 to give us 81. So what is the y-intercept? 0, 81. Good. If we know that our leading term is x to the 4th, can you go ahead and tell me the in behavior? If we know that the leading term is x to the 4th, can you tell me my in behavior?
Unlimited. No, infinity.
Infinity on both? Yep. So remember, an even power for your leading term, both your arms will point the same way. And if your leading term is positive, your right arm has to point up, so will your left arm. If it were an odd leading power, then that would be pointing opposite ways. X-intercepts, that happens when y equals 0. So we'll start with 0 equals, and then you have x minus 3 squared. But that would be, yeah, x minus 3 squared, and then x squared, then what? Plus 6x? Plus 9? How did you solve this? Oh, x minus 3, okay. What do we call that second one? Perfect square trinomial. And it factors in x plus 3 times x plus 3.
So this is where you got to do the end 2 thing.
Yep. So from x minus 3 and x minus 3, we're going to get the same thing. What will we get? X equals 3 with a multiplicity of 2. And then from x plus 3, we'll get the same thing of x equals negative 3, multiplicity of 2. It did ask for intercepts, so I'm going to write 3, 0 next to this one and box that with the multiplicity. And then I'll write negative 3, 0 here and box that with the multiplicity. From there, we can sketch a graph. What happens when my roots have a multiplicity of 2? They bounce. So, labeling my graph, I've got my y-intercept up here of 0, 81. And then I need an x-intercept of 3 and an x-intercept of negative 3. I'll label this one and label this one. And my leading term was x to the 4th, so that means my right arm should be going upward. But remember that 3, 0 has a multiplicity of 2, so it should come down, bounce, and then come back up, go through the y-intercept, and then you're going to come back down to this x-intercept, bounce, and come back up. So it's a W. What questions do we have on this? I thought you said it was terrible. That sounded fine.
Yeah, I don't know.
Don't know. Alright, hopefully we'll do day 3 tomorrow. Hopefully that one goes well. Let's do homework problems. Alright, we got 8 problems to get through today, just like yesterday. We're starting with number 22. What can I do with number 22? It says find the zeros, so what does that mean I'm going to have to end my problem with?
Number 22?
No, 0. No. What is it?
Oh my God.
Yeah, the zeros are the x-intercepts, so we're going to have to end these with ordered pairs. How can I start 22? Really? You don't want to do anything else? Take it out. Complete the square? Is there a way that I could make my life easier Multiply by 3. Tell me why I'm allowed to multiply by 3. Because it's equal to 0. Now, if it was equal to, like, y, or you're completing the square, you can't multiply an expression by 3. You can't multiply f of x by 3. But here, it's just equal to 0. So I can multiply by 3. What you do to one thing, you have to do to everything. 1/3 times 3 will be 1x squared, or just x squared. Plus 2x times 3 is 6x. And then plus 5 times 3 is 15. And that equals 0. Yes. But then you'd have to deal with your 1/3, wouldn't you? Yeah.
Dude, just shut up.
No. Not when you're solving.
Complete the square.
You want to complete the square?
That's like back.
So if we complete the square, then we would have to solve by square roots, right? Is this factorable?
No.
No. So we do have to either solve by square roots or we have to do quadratic formula. What do you want to do?
Quadratic formula.
You want to do quadratic formula? How about if you want to do quadratic formula, you do quadratic formula and I'll show completing the square.
Can you show quadratic formula?
Can I show quadratic formula?
Complete the square.
Okay.
I need to.
What is A?
1,
1. B?
6,
6. C? 15. Give me the quadratic formula.
1,
No, give me the formula. Negative B over 2A plus or minus square root.
B squared AC over 2A.
If you don't know that, I would write it down every single time you use it, because you need to know that. You do have a unit test on Friday, and you need to know it. So if you don't know it, write it down every time you use it. And then I'll plug my numbers in. So negative B is negative times 6 over 2 times 1 plus or minus square root. B squared is going to be 6 squared minus 4 times A is 1 times C is 15. All over 2 times A is 1. Negative times 6 is just going to give me negative 6. Every time I start a new line with the quadratic formula, I put x equals to remind myself of what I'm doing. Over 2 times 1 is 2. Plus or minus square root. 6 squared is 36. Negative 4 times 1 is negative 4. What's negative 4 times 15?
60.
Negative 60. Over 2 times 1 is 2. What's negative 6 divided by 2? Negative 3 plus or minus square root. And 36 minus 60. Negative 24. Can I divide that by 2? Right now? No. I can't divide that by 2 because negative 24 is underneath the square root and 2 is not. The square root is only in the numerator of your fraction. It does not go to the bottom. What can I do with the square root of negative 24?
6 times 4.
6 times 4, which one's the perfect square? 4. So we'll have the square root of, if 4 is the perfect square, put your negative with it, and then times 6 over 2. The square root of negative 4 is going to come out as what? 2i. So negative 3 plus or minus 2i square root of 6 over 2. Now that we have a 2 in front of the I and a 2 in the denominator, bless you, we can divide those. 2 divided by 2 is just 1. And so we're going to have x equals negative 3 plus or minus 1i is just I square root of 6. Oh, I need zeros, don't I?
Yeah.
Here's the thing. I may have messed this up yesterday, so if I did, I'm sorry. I clarified with Miss Tate yesterday, because y'all know I do have some misunderstandings here. What's the deal with imaginary solutions?
They're not real.
They're not real. And what happens on the graph if we have imaginary solutions? It doesn't go across what? The x-axis. So do we have ordered pairs here? No. So you leave it here. If it were real, then we would write them as ordered pairs because they're zeros. But it's not real, so this is as far as we can go. You can't write imaginary solutions as ordered pairs because they don't get graphed. Does that make sense?
Now we got number 9.
Go back and do number 9 on your own.
Guess I will.
How long do you need? 4 minutes? There's a reason you're doing number 9. It's because it's similar to number 22, so...
I'm gonna need more.
Hang on. 6 plus or minus 1/2 I. Is that right? I got the private
Okay, I'm lost completely.
Okay, which way did you go? We had a mixed variety of methods.
I went quadratic.
You went quadratic formula?
Yeah.
Mm-hmm.
Hey, what's where
Do what? No. Subtract 25 and 36. What is that? Negative. Are you sure?
Negative 83 over
Oh, it's negative 4.
Negative 11.
No, that's 25 minus 36. Oh, it would be negative 11, wouldn't it? It's negative 11.
Yeah. 5, 6 plus minus I equal 11 over 6. Why did I do 9 minus 12? Where did you get that? You had a wrong phone.
Gabe, I think the square root was negative 11. 25 minus 36? Yeah, that sounds a little bit more appropriate. This will be 5 over 6, yes? Plus or minus, you're checking your work if you use quadratic formula. 25, negative 4 times 3 is negative 12, times 3 again is negative 36, over 6. 25 minus 36 is negative 11. So you got 5 over 6 plus or minus the square root of negative 11 over 6, yeah?
Yep.
And then where can you go from there? You could just take out the square root of that negative, so x equals 5 over 6 plus or minus I square root of 11 over 6, yeah?
So
Can I write that as an ordered pair?
is the I included in the over 6?
Do what?
The I's included in the over 6?
Yes. The denominator is 6 and the numerator is I squared of 11. Hey, who got that right or got close? That's good. That's good. That's good. All right, let's go to number 10. What's number 10?
We didn't count.
Probably.
That's from calculator.
Number 10.
Do we have a dinosaur in the classroom?
Oh, cute. Actually, I think we graphed yesterday in our calculator. We can actually graph it without our calculator, so we might go down that route. You have 600 feet of fence. Are we ready? You have 600 feet of fence with which to build 2 adjacent pens for your animals as shown. Find the dimensions. What are dimensions?
What kind of calculator is that?
What are your dimensions?
600 feet.
No.
Length and width.
Length and width. Quit.
Grayson, shut up.
That will maximize the total area enclosed. What's maximize mean? Most, okay. In quadratics?
It's most.
In quadratics?
The max you can have.
In
vertex.
quadratics?
Oh, vertex.
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 Okay. Where do I start?
600 feet. You find your equation.
Okay. Divided by 2.
I don't know.
Where do I start?
That's Dixon's apple.
You're going to have to do this on your own in 2 days.
I really don't know.
Let's add Dixon's apple.
Wait, I got it.
Is there any buzzwords in our problem that would tell me kind of where to start? It showed me the adjacent pins.
We have 600 feet total.
Okay.
It equals 600. L plus
Okay.
W equals 600.
So we got 600.
Equals L plus W.
Is it just L plus W?
It's
So your pin is L and W?
It's 2. No, it's 2L 3W.
What?
Or no. 3W.
Where are you getting that?
2L 4W. Because there's three.
There's 3 widths and
Yeah,
2
2
lengths.
lengths and 3 widths.
Yep.
L and C. They all match.
So you have 2 L's and 3 W's. Okay. What else?
Dixon? Dixon? Yeah, Dixon. Did I see
You give me back my.
Any other ideas?
What's the area?
Ooh, okay, we got an area.
Yeah, what's the area?
Okay,
Length times
length times width, okay. We're trying to maximize the area, so we need to work with our area equation. Except our area equation has two variables in it. How do we fix that?
Divide by 2.
Where?
What would that do for you?
Oh, area. Area divided by 2.
No. Oh, you would have to. Really?
You have to get the length or the width by itself. Yep. Which one do you want to get by itself?
Length.
The length? Okay, so subtract 3w. So you've got 600 minus 3w is equal to 2 lengths.
Oh, and then you divide by 2.
Divide by 2. So you get 300 minus 3 over 2w is equal to length. If that's equal to length, then you can use this and replace your length in this equation.
Ah.
So we'll have area is equal to our length is 300 minus 3 over 2w times w. Hey, what form is that in?
Area.
Factored form. What does factored form reveal to you? Yeah. Couldn't we start sketching our graph with the x-intercepts? So if we set this equal to 0, then 0 product property tells me 300 minus 3 over 2w is equal to 0. And that tells me w is equal to 0. Can w be equal to 0? No. So we know that that's not going to be entirely useful except in the making of my graph. So I know that one of my intercepts is 0, 0. And then I can find the other one from 300 minus 3 over 2w. How do I solve 300 minus 3 over 2w? Add 3 over 2w. And you've got 300 is equal to 3 over 2w. Now what? I hope you don't. Multiply by 2? Do what? Probably. 300 times 2 is 600 is equal to 3w. Now what? Divide by 3. W equals 200. And that's my other x-intercept, right? So I have another x-intercept of 200, 0. Yes?
Yes.
And that is my width. What should my graph look like? Is it a straight line?
No, it'll probably be.
The leading term is what?
It'll probably be.
Look at our area equation. This guy. Where's your leading term going to come from? 3 half w times w, right? And that 3 halves w is negative. It's going to open down. So it's going to look like this.
Yep.
Where's the maximum area going to happen? At the vertex? Where's the vertex?
At the max. At 100.
So this would be 100 because it's half of 200 in the middle of 0 and 200. And then you can plug in 100. Plug it into where?
Oh, I see.
The vertex form. Or not vertex form, whatever that.
Your area formula. So area is equal to 300 minus 3 over 2 times w, which is 100, times 100. Yes?
Yeah. Yes.
Mm-hmm. So 300 minus, you did 3 times 100 divided by 2, which is what? 150. And that's times 100. Oh, so that turns into 150 times 100. Let's, because we multiplied 3 times 100, which is 300, and then divided it by 2. which is 150. So the fraction right here multiplied by 100. My highlighter messed up, but. And then is that feet? Did we double check that?
Yep.
Is it feet squared? That's your maximum area. What are your dimensions?
Still figuring that out.
Do we know the width?
Yeah.
What was it?
200.
What? The width, the x-intercept was 200. That wasn't the width of the maximum.
100.
The width of the maximum was 100 what? Feet. What did we multiply that by to get our answer? Did you multiply it here? Width. This would have to be your length?
Yeah.
150? Now, we're doing it by hand because there's a chance that you could have to do it by hand. What if it was on the calculator part? What could you do?
Right.
You could plug this in to your calculator and then just find the vertex, right? But you'd have to know what you're looking for on your graph, and you'd have to know what the input and output are. Questions on that one? Everything? It'll get better as you keep practicing. When you're ready, let's go to 11. It says find the roots, so what do my answers need to look like? X equals. So for number 11, what do we want to try? You want to try factoring?
I don't think no.
If it's roots, then that means our problem needs to start with setting y equal to 0, and then we've got 4x squared minus 3x minus 2. We could try to factor it. What are your factors of 4? 1 and 4, 2 and 2, and then what are the factors of 2? 2 and 1. Tell me which ones don't go together.
Probably 2 and 1.
Like, which numbers can you not put in the same factor together? 2 and 2 or 2 and 4. So we're very limited in what we can factor here. I can't do 2x and 2x because one of my factors of 2 is 2. So that would make a GCF, and I can't do that. So my only option for the leading term is 4x and x. My 2 cannot go here because then that would be a common factor with 4x. So my 2 has to go in my other one, and my 1 has to go with 4x. That gives me a 1x and an 8x. Is that going to work? Nope. Back to the drawing board. What do we want to try now? Do what? Tell me why completing the square is going to be rough. Why? You're going to have to take out that 4, then you're going to have to split whatever that is, and negative 3 is already odd, so that's going to be rough. Quadratic formula? What's A? 4, B? Negative 3, C? Negative 2. So I've got x equals negative times b is negative 3 over 2 times a is 4 plus or minus square root. B squared is going to be negative 3 squared minus 4 times a is 4 times c is negative 2 over 2 times a is 4. Negative 3 is going to give me 3. 2 times 4 is going to give me 8 plus or minus square root. What's negative 3 squared? 9. It's important that that's a positive or it's going to mess up your whole problem. What's negative 4 times 4? Negative 16. Then multiply that by a negative 2. Positive 32. And that's over 8. Now what? Add those together. So I've got 3 over 8 plus or minus the square root of what? 41. And that's over 8. What do you know about 41? It's prime. Is it a perfect square? No. What kind of number is the square root of 41? Irrational. Can it be added to 3 over 8? No. It is real. That's it. The roots is just x equals.
What is solution?
Solutions is x equals. Unless they're asking you for zeros or x-intercepts, it's just x equals. Alright, number 21. To 21? 21. Notice 21 is asking you for the zeros. So for this one, you're going to want to write them as ordered pairs. If it's not an I. Did we do that yesterday on 22? Oh, we already did 22 today. Alright, you're going to try 21 on your own. I'll give you 4 minutes. Add the 2. You're checking your work, yes. 2x squared plus 6x plus 2 equals 0. Take out a 2. X squared plus 3x plus 1, which is what told you it wasn't factorable, because the factors of 1 won't give you 3. And so here, a is equal to 1, b is equal to 3, c is equal to 1. In that step, you could divide both sides by 2, which is why we can ignore the 2. So just keep that in the back of your brain. X equals negative b will be negative times 3 times over 2 times 1. Plus or minus square root b squared is 3 squared. Minus 4 times a is 1 times c is 1. All over 2 times a is 1. Got a lot of 1s. Negative 3 over 2. Plus or minus the square root of 9 minus 4 over 2. So we get x equals negative 3 over 2 plus or minus the square root of 5 over 2. Square root of 5 over 2 is irrational. It can't be combined with negative 3 over 2, which is rational. And so negative 3 over 2 plus or minus square root of 5 over 2 comma 0. Because it is real, so you can write it as an ordered pair. Yes. You can separate them if you wanted to. For efficiency, I write them together with a plus or a minus separating them. Who got that right on their own? Good. I saw a lot of good things happening. Let's go to 12. These directions say find the roots, so we're good with just x equals. What form is this in? Vertex form. What's my very first step that you're probably going to skip over? Set it equal to 0. 0 equals negative 3 times x minus 4 squared plus 5. How are we going to solve this one? Yeah, we're going to solve by square roots by subtracting the 5 first. If it's already in vertex form, you can solve by square roots. You could expand it out if you wanted to, but if you expand it out and get it in standard form, you run the risk of it not being factorable and you doing all that work for nothing. So just keep that in mind. 0 minus 5 is negative 5 equals negative 3 times x minus 4 squared. Divide by negative 3. I get positive 5 over 3 is equal to x minus 4 squared. Now I square root both sides. Good. I'm going to show some work off to the side with the square root of 5 over 3 because that does take a little bit of extra work. Actually, I'm going to show it up here. That's really the square root of 5 over the square root of 3, and we can't have that. Why? We have a square root in the bottom that we don't know. It's irrational. How do I rationalize that? Yeah, multiply by a well-chosen 1 of square root of 3 over the square root of 3. That way we're not changing the quantity of our expression. We're just changing the way that it looks. That's why it's called a well-chosen 1. What's the square root of 5 times the square root of 3? Square root of 15. And what's the square root of 3 times the square root of 3? The square root of 9, which is 3. So in our next step, we're going to replace that left side with the square root of 15 over 3. The 3 is on the denominator. It does not have the square root on it. The square root of 15 is in the numerator only. And then that equals what? Absolute value of x minus 4. And that means we are ready for piecewise. So x minus 4, comma, negative x minus 4, comma. The minus 4 means I'm doing what? Right 4. So my first domain will be x is greater than or equal to 4. Oh, are you messing up? Okay, hang on. And that's x is what, greater than or equal to 4. Hopefully you're finishing this one. after my computer messed up. X is less than 4. Are you done with this? Are you? Is it all correct? Did it show the piecewise? Oh, then you should probably go back and do the piecewise.
But I'll do that on the test.
Will you?
Yes.
Because if you're not practicing it, the chances of you forgetting it are very high, right? So for x is greater than or equal to 4, you'll have x minus 4 is equal to the square root of 15 over 3. Add 4 to both sides. 4 is your rational number. It goes first. Positive square root of 15 over 3 is your irrational number. It goes last. I'm going to box that because it did ask for just the roots, right? Yeah, just the roots, so we're good with x equals. And then my other one is going to be x is less than 4. And for that one, we've got negative x times x minus 4. Negative x minus 4 is equal to the square root of 15 over 3. Divide by negative 1. That only changes your sign, so x minus 4 is equal to negative square root of 15 over 3. Add 4 to both sides. And x equals 4 minus the square root of 15 over 3. What questions do we have? I know. And it's unfortunate that you're used to that from previous classes that you've taken, but that will help you with a better understanding going to your next class. That's why we make you show it. Everybody ready to move on? Scream if you're not. Number 13? Yeah? I'll wait. Form is number 13 in vertex form. Says find the x-intercepts of the following using any method. Hey, what method could we use? Yeah, you could. Or you could graph it, right? We could graph it if we wanted to. Let's try to graph it, see what happens. Tell me how to graph this thing. Oh, okay, so we've got right 3 up to anything else? Rocks, reflection over the x-axis, and then a vertical stretch by 2. Can we like vertical stretch by 2? So we've got right 3 up 2 will be our vertex. And we've got our axis of symmetry running through those. And then I'll do 1, 1. 1, 1 reflected over the x would be 1, negative 1. Vertical stretch times 2 is negative 1, negative 2. Right 3 is 4, negative 2. And then up 2 gets me 4, 0. So that's one of my x-intercepts.
You know this starts with our text and do it vertical stretches.
If you know how, yes. And then my other one's going to be, my reflection point to that would be 2, 0. 3 points is enough, so good. If you wanted to put another one, you could. It'd be 1, negative 6 and 5, negative 6, so mine's a little off. Correct. As long as it doesn't look like a V shape. The only reason I make you do 5 is because some people will put 3 and then they'll do this. Yeah. Make it extra round. Yep. Alright, number 14. Same idea. But, okay, it's factorable. So, if it's factorable and I'm going to factor it, it should be equal to 0. And what do I multiply to get x squared? X and x. And then what do I multiply to get 5? 5 and 1. How do I get a negative 4? Minus 5 plus 1. From x minus 5, what is my x value going to be? X equals 5. And then from x plus 1, it's going to be x equals negative 1. That corresponds to the points 5, 0 and negative 1, 0, which is what they're asking us for. And then from there, if I'm graphing it, what could I do from there? Where's the axis of symmetry? 2. Okay. What could I do from there? How do you get your vertex? You can plug in 2 to your equation or your factors, right? So if I plug in x equals 2, I'm going to plug it in a factored form. Y equals 2 minus 5 and 2 plus 1. What's 2 minus 5? Negative 3. What's 2 plus 1? 3. And what's negative 3 times 3? -9, so your vertex is at 2, -9. Do we have any stretches or reflections or compressions? Nope. So it just follows your pattern about the vertex. 1, 1, 2, 4. That's plenty. You could also write vertex form and then say, okay, my vertex is right 2, down 9. And then you could transform 1, 1 from there to get some more points, but 3's enough. What questions do we have? Tomorrow is Thursday. We're going to finish this note set tomorrow. And then you've got your unit test on Friday. Stay up to date on your homework. I will be asking you to do homework problems from 4.12 and 4.13 on the boards tomorrow. So at least make sure that you know what you're doing there. Ask me